Hey, how's everybody? Untitled here. Welcome back to the show. So I'm outside right now because my pool pump that I've got has had a little problem. The Gfci that plugs into the wall socket is not turning on right now. I'll link the pool pump that I've got in the description below. It's a typical like Walmart brand pool pump, but what I've done already is I've actually taken apart the GFCI that plugs in, which there's a test and a reset button on this thing. I've taken it apart. I've used my iFixit screwdriver to be able to do this. Fair warning, there are two bits that are needed. One bit's the pretty common Phillips head bit. I used a #1 style Phillips head bit in order to get this. That's the one that's pretty easy to get. Most people have that. The one that is not so common is this guy that's on here. So this is in the iFixit bit. It is bit number 6 that has the 2 prongs. That's because there are 2 screws that come out that do this. So in order to get this guy off, what you do is you remove the 4 Phillips head screws on the bottom part first. That pops this whole thing off. I actually popped the grommet out just in case, just to see if there was something there. I actually didn't have to do this at the end. Then there is 1 Phillips head bit right down here that you need to be able to pull out, followed by the switching into the bits into the horseshoe. I don't know the name of this bit is, so pardon me, but there's like the horseshoe bit of the 2 that pop up in the corner with it right there. And then this, and then I think that was it. Maybe 1 additional bit somewhere within there. Anyway, then the whole thing will pop out of its case, leaving the 2 buttons behind. And you could see on here the exact thing that has gone wrong with the circuit. Actually, let me bring this around to the front for a second here and switch my, well, I can't even switch my camera view to be able to look at it, but you can tell I've got quite a bit of water damage associated with the circuit board. There are rusted components all over the place, including one of the main filter capacitors. It looks like it's received the most amount. I'm guessing it's a filter capacitor just because it's the biggest one. The underside of the circuit board actually appears to be more or less fine. I see a couple of through-hole resistors, and on the other side I see some chips, probably a regulator, a couple of other smaller components, but the top part is completely rusted through. So I'm going to kind of make a series of videos in terms of how I fixed it, how everything like that. Just so actually, one of the other things I noticed was that the contacts on the plug, because I have mine plugged outside into a regular extension cord, and the contacts were rusted. So I actually used a little bit of some sandpaper and a pair of pliers and just kind of I've already kind of cleaned those guys off and tested them with a multimeter. I'm still using the BK Precision multimeter that I was using before, the Test Bench 390A, to make sure that the contacts, or actually the contacts, when I touched it to the contact, they were a little bit rusted. So that was my first idea that there might be something wrong. But the actual button that does the test and reset was not functional to it at all. So let's see if we can dive in and take a closer look. Okay, folks, so I'm using my iPhone 12 to actually be able to kind of show a video about this. So please, it's not my usual camera that I use, the usual microscope that I've got, but actually I'm kind of looking at this right now. That has some great zoom quality. So you can see very much so up close that the, whatever this capacitor is, it's right here. I'm assuming that's a capacitor is damaged. There is rust marks all over the place. One of the things that kind of worries me here is that it looks like there should be some sort of a component right here. I'm not quite sure what that is off the top of my head. I bet you I would be able to actually buy this plug brand new, which I'm going to look for after I kind of start to clean it up just a little bit here. What I'm using to clean it up, though, what I'm actually using to clean the whole thing up with, I am using some deoxit electronic connection, so it removes oxidation, improves connections, and just in case, I also have some regular isopropyl alcohol with me. I am also using oh gosh, well, where did I put it now? You should see the mess that I've got kind of floating all over the place. Oh, it fell on the ground. That's why. I'm also using an ESD brush that I'm going to use in conjunction with the deoxit. The ESD is just, I don't think there's going to be any chips that have a large amount of shock values to them, but let's see what we got. All right, so there is the deoxit on there. I'm going to let that kind of settle in, kind of brush this in. I'm going to probably attack this in two different ways with this here. And yeah, generally speaking, rust is not good for any kind of circuitry, and I see a large majority of the rust is around where that bypass capacitor happens to be, so I'm assuming that that is the culprit. We're going to check that here in just a little bit to see what exactly that could be, if that's a problem with it at all. The ESD brush is kind of hard. It's pretty much, it feels like a toothbrush in a lot of ways, but it's actually kind of able to prevent static shock from building up, because like friction is a big culprit towards how static shock happens kind of in the first place with it. Oh, there's some rust up at the top part of it right there. There we go. A little bit of that clean. So now let's I've got some regular napkins actually to be able to kind of wipe up some of the gunk, kind of clean this up. Hey, if you like what I'm doing with it right here, leave a comment down in that comment below. Let me know if you're interested in seeing any more of this. I'm actually going to lift the through-hole capacitor up slightly because I want to be able to actually get underneath the large capacitor here. It actually looks like one of the contacts might be damaged. It's tough to tell from a bird's eye view like what I've got here. Let's see. Get a little bit more in there. Start to brush away. And again, I'm not a pump expert or anything like that. I'm just someone that teaches people how to solder and how to. I'd say 75% of all 75% of all electronic problems are either something is not plugged in, something has been disconnected because it's burnt, or something has been disconnected because water has spilled on it. So. And by 75, I really mean like 90% of all the world's electronic problems usually involve one of those three things. And of those problems, I would say a large majority of those problems are easily resolved with a power reset. This one, very much so, is not a power reset problem. This one is something that is quite different with that. Okay, so that is more clean than where it was. So now let's do some basic checks around where some of the damage was here. And I don't have a schematic. I actually don't really have anything to work with at all on this. So what I'm first going to do is I am going to test for capacitance on the capacitor. And by testing capacitance, I'm going to test for resistance of the capacitor, because if the capacitor has been shorted, and this is indicating 6.49 mega ohms. Actually, here, let me put that on the screen as well so that you can see what it is that I'm doing. So 6.49, it's going to be hard to try to do this to where I'm going across the leads right now, and that's indicating some bit of an overload, but the resistance is sort of dropping with that. So there may be some damage associated with that particular part as well. I am not reading anything on the meter itself regarding capacitance, so the actual, sorry, this is hard to do with the meter being kind of over there. Let me see if there's a better spot for me to be able to kind of run some of this stuff. Sorry about that. Please excuse normally I have it on the computer screen where you're able to actually see that. So nothing is showing up there, but in addition to that, nothing is also showing up as a short. Right now, normally when you when you test resistance on a capacitor, if the capacitor is good, then it should slowly but surely raise in its resistance to a large value, because the internal parts of the multimeter have a power supply that tests for the resistance of something, and if the capacitor is good, like this one is demonstrating to me right now, then it should be charging up to the point where the actual it would eventually get to an infinite ohm resistance. If it was bad, that would mean that it would have either a very, very low resistance, or it may be that it's completely overload, which means that it's shocked open. But that also may mean that the capacitor is charged up. For a smaller capacitor like this, I'm not too worried about that. in terms of where that is. I do notice that there is underneath the capacitor connection here, I don't know if you can see that, there is some rust there as well. So I'm going to kind of try and brush that away with a little bit more deox. Let's see if I can't see if there's a potential connection problem there. It actually looks like the bottom part of this circuit board has it's a single-sided circuit board, so there are no connections on the bottom side, so that is just a through-hole mount, and they have soldered the capacitor. That actually probably means that this circuit board was soldered by hand. Now that I'm actually thinking about that, it means that it was probably soldered over by hand, at least on the top part of it right there. But some of these other pins that are here may actually need to have the touch of a soldering iron and some fluxing agent just to re-tin them over. You can tell that, like, for instance, some of, like, this pin right here, that one's in pretty bad shape. Same with, like, this pin, in particular, this pin right here, which actually looks like it should have a trace that goes to this resistor, this 3.3 kiloohm resistor right here. It looks like there should be something associated with that as well. Right now I'm using a Q-tip. I don't know if you can tell this. I am using a Q-tip to kind of wipe away some of the additional corrosion that has occurred on the surface of this. I'm gonna spray a little bit more of that. You can hear the kids screaming because they can't go in the pool right now. I'd be screaming too if that was me. And we're actually going to test. I'm actually going to test that particular part of the Gfci circuit right here. I'm going to test to see if this pin, it looks like it is soldered to that point. I'm actually kind of using the camera right now to get a better look. It's kind of hard to tell. It's actually very hard to tell, and I don't want to poke at it with a pair of tweezers. I'm just trying to remove material that's located on the surface of the part. I need to be looking a little bit more at the at here. I'm actually going to use a little bit of some isopropyl alcohol now and try and get in there again. See if that removes any additional corrosion. Honestly, the deox seems to be working pretty well, I must say. So there was definitely a link between here and here. I could see that very easily. And remove some of the additional sorry about that. I'm going kind of quiet right there because I'm just trying to see, I'm trying to make the determination of whether or not that one line is what may have caused the damage. Like this was maybe some sort of like a tin whiskers like problem with that, and it's sort of hard to tell. Not gonna lie. So let's pause for a second. Let's take some multimeter readings. So I'm going to take, actually I'm going to put this and set this to just doing continuity. Continuity is a test of open and shorts. Touching the probes together like this, and I get I get a short and a beep and an audible beep from the meter. And open means that the meter is overload and not there. So let's test a few things here. Are these guys shorted? No. Those two appeared to be shorted, and they kind of look like they are meant to be shorted as well. Are these two shorted? No. Actually, I'm having a hard time making a contact with this pin, so I'm not even sure. I might need to have some additional cleaning done. Yeah, because I can barely, in this one burnt pin, I can barely make a contact to that pin at all. So I think what actually has to happen next with that particular pin is we may need to apply some flux and some solder to there with a fresh hot iron and actually re-tin that over. So let's do that in a follow-up here. Okay, so I brought my soldering iron out here. You can see there's the soldering iron in place. But I've actually found something else. So as it turns out, my wife, Mrs. Chontek, actually bought a spare pump, and with that spare pump actually came an entirely separate plug. So I'm actually going to use this opportunity to take the other one apart and see what it looks like, because there may be spare parts that I might be able to kind of cobble out of the old one with it. So let's see here. So let me move the multimeter out of the way. All right. And I'm going to move the old plug out of the way too. And let's take a look. Oh, let's take a look at the new plug. I'm going to kind of, sorry about the earthquake over there. Excuse me. Pardon me. Gee. All right, let's put a little base that it holds the wire steady to it there. And okay, so let's start. Looks like there's some Phillips heads and, oh gosh, what are those? A triangle? A triangle? Do I even have a triangle? I have a triangle. There's a triangle bit. Wow, that's weird. What is it with pool pump people? Why do you not want people to get into there? Okay, well, fine, that's whatever. It's fine. So I'm gonna start by taking the first 4 screws out. Easy enough done. And again, I'm using the iFixit kit, one of the sets of screwdrivers. Honestly, the screwdriver is pretty nice. The bits are awesome. I highly, actually, very much so, highly recommend picking one of these up if you're going to be doing any kind of, you know, repairs of any sort with that. All right, so first 4 screws are out, and I've put them into the tray. I have just lost one of them, and oh, there it is. Sorry about that. Hello, arm. How are you? Okay, so first 4 bits are in the tray. Now I've got to, okay, triangle. Triangle? Hey, triangle. Oh my gosh. I don't know what kind of bit this is. It's marked in here in the bottom left-hand corner. There's 2 triangle bits, but only one of them actually fits. And again, thank you iFixit for putting a bunch of random bits that I never thought I would actually use into a kit that I am now actually using right now. So, triangle bit. Oh, that one's got some torque needed for it. Even the screw looks odd. Look how chipped the corners are in this thing. Looks like an old Simon Says. You know, like one of those Simon games. Ugh, boy, that has got some turning torque needed to turn that thing. Okay, and so now the bottom part should just pop off to it right there, and there's the 3 terminals for that. But now I have to kind of dig a little bit, and it looks like I may actually have to remove this grommet as well in order to get at the bottom screw that holds the whole thing together. So now I'm going to turn these screws here to get access to the wire. Put those in the upper left-hand corner of my tray. Make sure I'm looking at this all on camera. All right, there we go. So those screws are out. Now I have access to, and actually I can see where the grommet, I'm gonna have to be careful as I pull that thing back in. Oh boy, that is, I really have to turn that guy hard. I didn't think I had to turn the other one all that hard to actually do this here. But this one, sheesh, that is a very, very hard bit to turn. Okay, so everything's out now at this point. And here is my circuit. And I am in luck because it looks like they are the exact same thing. They both have the Defond EM1073 model on it. They both have similar resistors in these parts. That's a 322, that's a 470. Although these look like they're in much, much better shape in terms of where these are. There's a bug crawling on my leg. Hopefully that was an ant. All right. Looks like there's a unlabeled resistor right here, a capacitor. Now I just want to test this capacitor's resistance out because I just want to test to see what this guy says. So I've set my multimeter to measure resistance. I'm going to touch my probes across the capacitor, and it has a similar reading, although a much lower reading. I would say very similar but lower reading in terms of where that is. Almost, yeah, this one says 0.7 mega ohms and it's holding steady, whereas the other one says about 6 mega ohms. So the other capacitor may just have some other junk to it on there that may be causing it to have some sort of an issue with that. But one of the things that I can see much better on this circuit board here is what's open, what's short. So for instance, I'm sorry I don't have a little thing to hold this still. That is, so these two are open, those two, so the middle pin is supposed to be tied to the 322. That makes sense. And this is not supposed to be shorted to either one of those. All right, and then this pin, there's no pad on this pin. What? Well, maybe it's just not used or anything like that. Okay, so that's actually kind of reassuring that I actually, ooh, sorry, major earthquake there. I'm pretty sure that I could take this circuit board out by just unscrewing the wires at the grommet and replace it again with the one over here that's kind of borked. All right, because I don't know if those things are going to be connected together. So what I'm going to do is I'm going to apply some fluxing agent and the soldering iron. I'm going to turn my soldering iron on. I'm going to turn, oh, was it on? Nope, it wasn't on. Oh, I gotta figure out why that didn't turn on. Oh, is it because my power plug was loose? That's why, in the back of the soldering iron. Small technical difficulties. Sorry about that, folks. All right. All right, so I have got some fluxing agent, some Amcor Amtech fluxing agent. What I'm going to do is I'm going to put the fluxing agent all over the parts where I see where there's corrosion, and all I'm going to do is just re-tin them. I'm not soldering anything new to these parts. All I am doing is I am running the soldering iron over. I am at currently a temperature of 600 degrees Fahrenheit, and here is my nice and tinned tip. And so let's start this process here. I'm going to zoom this in a little bit so that you can kind of see, and I can also kind of see what's going on here. And the fluxing agent, so the flux, that's going to help in terms of additional oxidation cleaning off the surface. And I'm probably actually going to hit this guy twice. And you can see there's material that's dissolving with the heat with that. There we go. That actually looks even worse than where that was. It might just be I may have removed some solder from there. We'll have to take a little bit of a, something is making a funny sound with that. That may actually need more solder. So that's actually one of the pins of the IC that I believe is causing a lot of the issues with this. So one of the pins of the IC looks like it's actually just completely, yeah, one of the pins of the IC is not connected, I think, to anything anymore. I think it's actually not connected at all. So what I'm going to do is I'm actually going to see if I can't take a little bit of some solder from another pin, like this one right here. There's a little bit of some excess amount of solder that holds. Nope, can't get it from there. Let's try it maybe from this connector here. And that definitely looks a lot cleaner, but the excess solder that I've got, I'm trying to apply it down to that pin. That pin might just be gone on this chip. In fact, now that I'm looking at it, yeah, because like that pin's there, I can feel a pin right here, but on this one, like I actually can't feel any part of that connecting over to the rest of this. I don't know what the pin does off the top of my head, but I assume that the other pins are probably there for a reason for that. That might right there alone tell me that it's time to just switch out the plugs with that. Because if that guy, like if that pin's just rusted away, which it sure as heck looks like it is, if that pin's just rusted away, then there's almost nothing I can really do outside of just replace the chip, which means going even deeper into this, and I'm not really a big fan of actually doing that. All right, so now let's, now that that's clean, let's clean off the fluxing agent with some deox and a little bit of some brushing. Oops, sorry, making sure I'm doing this on camera. Yeah, that pin very well, it could be just gone. Could be gone into the ethos, wherever good pins go. Electronic heaven. There's probably a spot up there like that, right? Somewhere? I don't know. Yeah, just looking at that, I am not a fan of what that looks like in the least. I think that is, even if I tried to solder a new pin down onto there, I don't think that's going to make a damn bit of difference. But everything else, looking at this, these two circuits appear to be more or less identical. And so what I'm going to do is actually just straight up replace them, is what I'm going to do. And this other pump, this spare pump that we've got, to which my wife has stated that the spare pump, the spare pump is just an extra pump that the filters just did not fit. So it goes white, green, and black. Black goes into the brass. That the spare pump is just there just because she happened to find a decent deal with it. But good deal on her. Good deal on her. So anyway, we'll cut to this. I'll reassemble this here in just a little bit, and then we'll come back to here in just a second. Well, that did the trick. Replacing the bad circuit board with fortunate to have the good one with it on here. So, but yeah, the pump model, we've got the 0.4 horsepower roll you clear. What does that say? 904, number 90401E. Intertek. It's just a cheapy Walmart brand kind of pump with it on there, but it's one of those, hey, the pool doesn't work without it. This circuit board was the problem with it on there. So and then yeah, now I gotta clean up my workstation. Oh boy, what a mess. So it on there, but yeah, luckily we had the extra pump, so we're just going to order an extra circuit in there. But that's how that's done. Hey, thanks for joining me on this episode of Sean Tech. If you like what you saw with this here, leave a comment down in the comment below. Like, comment, and subscribe, and other YouTube crap that's on there, and we'll see you around on the next one, folks. See you later. Bye bye.